Hello everyone. In this video, we are going to study about the block diagram reduction rules or technique. What is the block diagram? First, we'll see definition of block diagram. So, block diagram is nothing but a pictorial representation of the functions performed by each component of the system. Then, what is why we use block diagram? So, it shows the flow of signals and it consists of many components linked together to perform a specific or particular task. Each component can be represented with the help of individual block. So here each block diagram has five basic elements. First is block, then next one is a transfer function of element, then third one is summing point, fourth one is arrow, and fifth one is takeoff point. So first is a block. These are the basic elements of each block diagram. First one is block. So this is one block which is having input and output. So here transfer function of elements. Now in the system there will be a transfer function. What is transfer function? Is that it is the ratio of Laplace transformation of output signal to Laplace transform of input signal by assuming all the initial conditions to be zero. Then one summing point. Summing point means when two blocks are connected to each other. This is my input signal, input, and this is my output signal. Okay. In control system, input is represented by R of S and output is represented by C of S, and this is my block. We can say that control system block. Okay, and here the output C of S is taken back to the input or feed back to the input. So here one summing point will be there. To add this point, this will be like this. So this is called summing point. This point is called as summing point. And arrows, so the arrows are showing the, this is arrows which is showing the signal, flow of signal. And takeoff point, so this output is taken back to the input, so this point is called as takeoff point. Okay, now control system, block diagram of control system. This is my control system which is having one input and output. Then types of control system, there are different types of control system. First one is a continuous time control system. What is continuous time control system? So here the input and output are signal of continuous time signal. That means which continuously varying with respect to time or have a continuous values. And discrete time signal, time control system is nothing but which is having a particular value at a particular time. So suppose this is my one signal, and so here this is called continuous time signal which gives the value at every instant of time. And discrete time control system means which gives the value at particular instant of time. This is the example of uh, discrete time. So here it is giving the values at a particular instant of time, and here it is giving the value at continuous instant of time. Then SISO and MIMO control system. What is SISO? So single input, single output control system. That means which is having only one input and one output, and multiple input, multiple output. That means which is having more than one input and more than one output. Then there is one open loop control system and closed loop control system. So in open loop control system there is no feedback element present. That means there is no relation between output and input, so there is no feedback element present. So the action is independent of desired output. This open loop system, there is no relation between input and output. See here, this is a reference input and this is a control output, so there is no relation between this output and input. Hence there is no need of any feedback element because there is no relation. Therefore this particular system is called as non feedback system, because there is no feedback and there is no relation between output and input. Therefore it is called as non feedback system. Then we will see the closed loop system, which is called as feedback control system. And in control system, there is a relation between output and input. One output is fed back to the input to modify the errors, while one signal is taken from output and it's fed back to the input. So this is my output C of S. So one signal so this one signal from output we are taking back to the input. Okay, so this is called as feedback. Next, this feedback signal is compared with the reference input and generates one error signal. Now this error signal is applied to the controller and output gets corrected. Hence, this system is said to be feedback system. Then types of feedback. Now again, in feedback there are two types of feedback: positive feedback and negative feedback. For positive feedback, uh, the positive feedback adds the reference input R of RS and feedback output CS. This is the output C of S, which get feedback to the input. So this is H is representing feedback element. This is a positive feedback because here the positive add plus sign is there. So this is a positive feedback, and the transfer function for positive feedback is given by G divided by 1 minus G H. Then for negative feedback, which reduce the error between reference input RS and feedback output. So this is the output C, which reduce the error between reference input and the output. So here this is the feedback element H, and here negative sign shows the negative feedback. For negative feedback, T will be equals to G divided by 1 plus G into H. This G element forward path element into divided by 1 plus GH. Then block diagram reductions rules. There are different reduction rules to reduce the block. The steps to reduce the block diagram: first is reduce the series block. First we have to check, is there any blocks are in series. So if yes, then reduce that series block. Then check the for parallel combination, reduce the parallel block. Then check for feedback loops, then reduce first minor feedback loops, and if possible shift summing point to left and takeoff point to right. So this is a summing point, this is a takeoff point. So we can shift or summing point and takeoff point. Then repeat the above steps till canonical form is obtained. Then okay, so rules of block diagram reduction technique. First rule is check the blocks are in cascade or series. Then if two blocks are in cascade or series form, are in series, then equation y will be equals to x into g1, x into g1 into x into g2, this block. And if we take x common, so it will become x into g1 into g2, and they are converted into single block by multiplying. So here it will become x into g1 g2. So equate after equating, these two equations are same, so the series blocks are converted into single by multiplication. Then rule 2: if the blocks are in parallel, then the blocks are added or subtracted depending upon the summing point signal. Now these two blocks here, summing point is there, so depend upon this summing point signal, we can add or we can subtract these two blocks. So the output y of s will be equals to y1s plus y2s. So what is y1s? So here y1s is equals to g1s into x of s, and y2s is g2s into x of s. So it will be g2s into x of s. So the equation, total equation will be y of s equals to g1s into x of s plus g2s into x of s. Now here we take g of x of s common, so it will become g1s plus g2s into x of s. So here we can add or we can subtract by use it, which depends upon the summing point. So here g1s plus g2s, so it will be add or we can add or subtract, so it depends upon summing point. If there is a plus plus sign, then it will get added, and if it is a minus sign, it will get subtracted. Then moving summing point after the block. Now this is my block and this is my summing point. I have to move this summing point after the block. So my summing point, I have to move this summing point after the block. Okay, here y of s. So the equation y of s is equals to g of s into this x of s get added here in r of s, so it will become r of s plus x of s. So here g of s multiplied by r of s plus x of s, and if we multiply here g of s, every time it will become g of s into r of s plus g of s into x of s. Now to move this summing point after the block, like this is my block and I have moved this summing point, so the equation will be y of s, here y of s is equals to this g of s into r of s plus x of s. Now compare these two equations, this is one and this is second equation. Compare these two equations. So here in second term of the equation, g of s is missing. Okay, so here to add g of s or to equate this equation, we have to add here g of s. So how g of s get added? So here we have to add one block. Okay, here we have to add one block, that is of g of s. So here we have added this block g of s and we have equate this equation. So the both equation will be y of s is equals to g of s into r of s plus g of s into x of s. So to move the summing point after the block, we have to add one block, that is of g. Then next rule, moving summing point before the block. Now this is my block and I have to move this summing point. This is my summing point. I have to move this summing point before the block. So the equation y of s is equals to g of s into r of s plus x of s. After moving this summing point before the block, we get the equation y of s is equals to this g of s into r of s plus x of s and g of s multiplied by x of s. Now here, see this, compare these two equations. So here in second term, this term g of s is the extra term. We have to delete this g of s term to equate these two equations. How to now what which term should we have to add here? So we have to, if we multiply 1 upon g of s here, 1 upon g of s. Okay, multiply this equation with 1 upon g of s. So this g of s get cancelled and this equation will be equate. So um, to move the summing point before the block, we have to add one block, that is of 1 upon g of s. So the equation will be same, y of s is equals to g of s into r of s plus x of s. Here g of s get cancels and here it will become g of s into r of s plus x of s. So to move summing point before the block, we have to add one block, that is of 1 upon g. Then next rule, moving takeoff point after the block. Now we have to move the takeoff point. This is my takeoff point. We have to move the takeoff point after the block. So we have to add one block, that is of 1 upon g. And to move this takeoff point before block, again we have to add one block, that is of g. We will see one example. This is the one example. We have to reduce this blocks into a single block. So first check for the series combination. Yes, these two blocks are here, two blocks are in series g1 and g2. Now when the two blocks are in series, they are converted into single block by multiplication, by multiplying it. So this g1 g2 blocks is converted into single, that is g1 into g2. Now check for the parallel combination. Is there any parallel combination? So no, there is no parallel combination. Then move towards the feedback loop. Yes, these two blocks are in this loop is feedback loop. So here, this feedback g1 g2 and h1 is the feedback to this g1 g2 loop. So here this is the negative sign is there, so this is a negative feedback. So the negative feedback, the formula to convert negative feedback is T is equals to G upon 1 plus GH. So this two minor feedback loop is converted into single block by using this formula, G upon 1 plus GH. So this is my G block, G1 G2, this is my G and this is my H. So here G1 G2 whole divided by 1 plus G1 G2 into H1. So this block are converted into single block. Then check, next check for the series combination. Yes, these two blocks are in series, so it will become G3 plus G4 into G5. This two blocks are series, so they get multiplied, so G3 plus G4 into G5. Okay, now check for the feedback loop, minor feedback loop. So this is the minor feedback loop. So again, this is negative feedback, so convert it into single by using the formula T is equals to G upon 1 plus GH. So now this is my G block, this is my G block, and this is my H feedback loop. So this is G3 plus G4 into G5 divided by 1 plus this block G3 plus G4 G5 into feedback loop, that is H3. So now these two blocks are in series, or we can say that cascade, so convert it into single block. So this cascade form is converted into single by multiplying it. So G1 G2 into G5 into G3 plus G4 whole divided by this 1 plus G1 G2 H1 into 1 plus G3 plus G4 G5 into H3. Now these two blocks are in uh, feedback loop. So here it is positive feedback. So the formula for positive feedback is G upon 1 minus GH. So now this is the this whole block is G, and this is feedback loop H. So here convert this. So this whole term is G. So G, this is G divided by 1 minus G into this is G term into H. This is my H2 upon 5. This is my feedback loop. So G into H. So now solve this, solve the denominator. So it will become 1 plus G1 G2 H1 into 1 plus G3 G4 G5 H3 into G5 minus uh, this term G1 G2 G5 into G3 plus G4 into H2, and the whole divided by this term. So after solving this denominator, this term gets cancelled, 1 plus G1 G2 H1 and 1 plus G3 G plus G4 G5 H3, these two terms get cancelled. Just this G5 get multiplied with this G5, and it will become G5 square. So uh, this is converted into single block. So G1 G2 G5 square into G3 plus G4 whole term divided by this particular term, 1 plus G1 G2 H2 into 1 plus G3 plus G4 into G5 H3 into G5 minus G1 G2 G5 into G3 plus G4 into H2. So this is the conversion. We have converted that block into a single block. Hope you have understood how to reduce the block.